Yo, what is up guys? Michael here, back at it again with another video, and today we're going to be comparing a human mathematical proof to an AI proof. So, some of you might be wondering, what exactly is a mathematical proof? And I'll explain it to you. The definition I found online is a proof is a rigorous deductive argument that establishes the truth of a statement beyond doubt based on axioms, definitions, and theorems. Sounds like a lot. Promise is very, very simple. All it really is a written argument explaining why a theorem holds. So for example, I think we're all familiar with the Pythagorean theorem, where if we're given a right triangle with sides A, B, and C, we know A squared plus B squared is equal to C squared. The proof behind this would be the written reasoning for why this theorem holds. I'm not going to get into it because it's pretty convoluted, but that's just basically what a theorem is. So for today's video, we're going to cover the intermediate value theorem, which states that let f be a function from a to b on the reals, be continuous, and let y be any number between f of a and f of b. Then there exists a c in ab such that f of c equals y. This sounds like a lot, again, but I promise you, it's pretty simple. All it's really saying is that given a continuous function, so continuous means that whenever you graph it, the graph should look something like this, where it's a constant straight line, there's no holes, there's no breaks in the graph, it just goes on forever. Something that's not continuous would be something like this, where you have a line like this, there's a whole line like this. Because this is here and you have to pick up your pencil while graphing it, it means it's not continuous, so it doesn't hold for those. But if it looks something like this, then you're good. And what it's saying is that given 2 points A and B here, let's say this is -2, right? And this is +3. What it's saying is that at some value for x when you plug it into the function, on this interval right here, you can find every single number between -2 and 3. So at some point it's going to be 0, somewhere here might be 1, somewhere here might be 2, somewhere here probably -1. That's all it's really saying, is that if you're given 2 endpoints, you can find every single value between them on the graph. So the way we're going to prove this theorem is by using Bolzano's theorem, which is very similar. So it's saying let f be a function and be continuous. If f of a and f of b have opposite signs, then there exists a c between a and b such that f of c equals 0. So instead of saying given f of b and given f of a, that every single number falls between them, what it's saying is that if one of them is positive and one of them is negative, at some point along this line, it's going to have to cross the x-axis where it is equal to 0 at this point c. So let's begin on how we can use Bolzano's theorem to prove the intermediate value theorem. So first thing we want to do when writing a proof is use our let statement. So for us, we will say let y be a number between f of a and f of b. Next thing we always want to do when writing a proof is state it exactly what it is we're trying to show. So for this instance, we want to show there exists a c, so set f of c equals y, which is what it is said right here in the intermediate value theorem. So our first step when we actually begin the proof is now define a new function g of x equals f of x minus y. The reason we want to do this is that we can use Bolzano's theorem to show that g of x is equal to 0. And once we do that, then that means f of x minus y will also be equal to 0. And then once you add y to both sides, you're left with f of x is equal to y, which pretty much completes the proof because we'll just have it right there, which is exactly what we're looking for. So let's go on to the next step. So we can say, since f is continuous on AB and y is a constant, then g is also continuous on AB. So let's try to visualize that. So say this is our graph f of x right here, minus. Whenever we would subtract a constant or add a constant, so whenever we subtract one, all it does is move the graph down to something like this. But if we add a constant, it'll just move it up. The shape of the graph doesn't change. I know my lines aren't straight, but you get the idea. The shape never changes. All it does is move it up and down, meaning it'll never not be continuous. So that's our first step. We want to prove that it's continuous, and we got that. Now we want to evaluate the endpoints at g on the interval. So let's say g of a is equal to f of a minus y, and g of b equals f of b minus y. What we can do with that now is, since y lies strictly between f of a and f of b, it follows that g of a and g of b have positive signs. So to illustrate that, let's say that this green dot right here is our f of a, and this blue dot right here is our f of b. Because y has to fall between these two values, they'll never change their signs. So for example, let's say our f of a is +2. That means y has to fall somewhere along this interval right here. So let's say that it's greater than 1, right, or greater than 0, sorry. So it goes from 0 all the way to 1.999 repeating, and it never touches 2. Because the number will never be greater than 2, so the number is going to be between 1.999 and 0, that's never going to be greater than 2, so 2 minus any of those numbers, it will stay positive. Now if we were to choose, say, a number that's negative from 0 to negative 1, a negative number, if you subtract the negative number, all you're really doing is actually adding that number, so we'll get 2 plus whatever, and that's obviously going to stay positive as well. So now let's go look at it from B. A similar argument can be made. So say we choose a number from here. Obviously, a negative number minus a positive number is going to be a further negative number, so it's always going to change. And because, say we choose a negative number on the interval from here to here, because this is negative 1 right here, all these numbers are going to be less than 1. So when you subtract the negative number, you're actually adding, but you'll never add a number that's greater than 1, so it'll always stay negative. So since we proved that this function right here, these two functions are continuous, and also they have opposite signs, then we can now apply Bolzano's theorem, which states that there exists a c such that g of c equals 0. Now we can say, because we had f of c minus y equals g of c, now we can say f of c minus y equals 0, and then we add y to both sides, and we are left with f of c equals y, which that's what we were looking for at the beginning, that we stated it right here. So since we got that, now we can say since f of c equals y, the intermediate value theorem holds, and thus the proof is complete. I hope that was all easy to follow. Again, the steps are listed. They're pretty simple. Only 3 pages, but yeah, since we're able to use Bolzano's theorem, we found the 0, and then able to say f of c equals y. Now we can find any point between those 2 points, and the theorem is done. Intermediate value theorem holds. So now, let's move on to the dreaded AI proof. Boo! So here's what happened when I first asked it to prove intermediate value theorem. It says, here's a clean, rigorous proof of the intermediate value theorem. Then it starts going into using the completeness of R, starts defining a set for some reason. I don't know what it's trying to do. And then now it's breaking into cases, and now it's saying by continuity of f at c, there exists a delta greater than 0, such that absolute value of x minus c less than delta. It's like, what are you trying to tell me? You know what I mean? It's like, if you're trying to use AI because you assume it'll give you a shortcut to an easy proof, clearly it doesn't, because I feel like this proof right here was pretty simple to follow. This is is using a bunch of theorems. I don't know what we need the supremum for. You might not have heard of that. I don't know why we need that. It brings it up twice. It starts using contradictions. One of the proof techniques we learned is proof by contradiction. So instead of proving because this is true, we could say if this is not true, then this is also not true. And when you do that, you always start the proof by saying, we will proceed with contradiction. The AI does not do that. The AI just states it as it comes up. So even if you try to pass this off as your own work, even if this is correct, people are going to look at it and be like, why are you formatting it like this? No human formats it like this. So that's one problem with AI. The other major problem with AI that human proofs don't normally have to deal with is that AI knows pretty much everything. If it's on the internet, it knows it. Us as people, however, we don't know everything. That's why when I was going through the proof here, I would explain each and every step, like at the beginning of the proof. Where is it? Right here. I explained why I chose this g of x equals f of x minus y, because once you apply Bolzano's theorem, you get 0, and then it becomes straightforward from there. With the AI proof, however, they just start going. They just try to go from point A to point B without explaining why they're doing it or what it means. They just say, oh, let's define this set. Okay, now let's try to find this delta value. Then it's like, where are you getting this from? How do you know that this is a thing? Why can't you tell me about it? And you kind of just have to take AI's word for it. Meaning, if it ever makes a mistake, you'll never know that it makes a mistake because it's not telling you where it's getting its information from. It's just telling you things. And once again, people try to use AI as some sort of shortcut to make life easier, but I feel like this is not easier to follow than the proof that we already stated before. So, to compensate, I asked ChatGPT again to prove an intermediate value theorem, using Bolzano's theorem this time. And the first issue that comes out to me is that they use an alternative definition, where instead of saying if f of a and f of b have different signs, they say f of a times f of b is less than 0. This is logically equivalent and still works, but if you're someone that's first learning about this theorem, this one might not be as obvious what f of a times f of b being less than 0 means. Like, it may take you like a new learner a few minutes to, or like a little bit amount of time to figure out, oh, that means they have opposite signs. I think it's easier to just explicitly state that rather than just do it like this. Again, if you're already familiar with it, you can do it like this because it's shorter to write, but if you're first learning, I wouldn't write it like this. The next issue I have with it is that it just says goal right here, which, like as we said in our proof before, is that we always want to say what it is we want to show. But for us, all we want to show is f of c equals y. In this proof, it's just saying, oh, our goal is intermediate value theorem. Yeah, obviously it's intermediate value theorem, but this is the goal, not any of this, just this. So, I'm not really a big fan of how it does that. Again, I feel like I'm nitpicking, but again, it's these small issues that add up over time, you know? And then let's go on to the next page. Then it starts bringing up assume without loss of generality, f of a less than y, less than f of b, that's fine. They also bring out this new function g of x equals f of x minus y. But the problem is, they're not stating where they're getting this from. They just write it and then continue on with the proof without ever explaining how it's going to come into play. They're just writing out each individual step without explaining why they're doing each individual step, and you just have to follow it and just hope that it's right. It doesn't say where it's getting this from. Now, and then when we go down to step 2, it does the same thing with the g of a equals f of a minus y less than 0, and g of b minus f of b, or f of b minus y is greater than 0. It doesn't explain why they're less than 0 and greater than 0. It's just saying that it is, and now you can just straight up go to Bolzano's theorem, and it's like, how do you know that? That's what separates us from AI, is that it just assumes we know everything without ever explaining why it's doing what it's doing. So now with that said, let's try to see where it goes from here. So once it does that, then it applies Bolzano's theorem to get g of c equals 0, and then does the same exact thing we did before right here. And then once they get f of c equals y, the theorem is closed. So was AI wrong? Not really. It still got to the point. It listed out its steps. If somebody were to do this on an exam, they'd probably get full credit, maybe 1 or 2 points off max, just for some formatting issues. But other than that, the AI, at the end of the day, was correct. But we're not arguing about correctness when it comes to AI. We're arguing about trustworthiness. And because it skips steps and assumes information, I wouldn't trust it. Especially if, like, if I ask it for a proof, I'm not just copying and pasting the proof. I'd probably analyze what it's doing, why it's doing it, where it's getting its numbers from. I'm not just going to be like, oh, okay, g of x, whatever, I'll just copy this down and go on. Because, like, I don't know why it's doing it like this. Obviously, this proof was a lot more difficult than the other one. Don't know why it did it this way first when Bolzano's theorem was a lot simpler. So, do I think AI is too powerful? Is it going to take over the world? Probably not. That's also an argument for a different video, so let's just cross that out. However, I don't think AI is completely useless. At the end of the day, ChatGPT did write a correct proof. Sure, it had some formatting issues along the way, but it did get from point A to point B. The problem I have with AI is the over-reliance some people have on it. AI is supposed to be a tool to make our lives easier, not make all of our decisions for us. If all the work we turn in is AI generated, what's the point of going to school or going to work? At that point, AI is just living our lives for us. When humans make a mistake, we adapt and we learn from them. When AI makes a mistake, we either don't notice or simply just ask it to try again. Forget the mathematical proof aspect of it. Work done by AI is soulless, while work done by people shows passion and a purpose. And that is what separates us from AI. And I think that's all I got for you guys today. And thank you all for watching. See you soon.